In this video, we will talk about the importance of changing order of integration for iterated integrations. So the example we have is an integration from 0 to 2 from y squared to 4 square root of x sine x dx dy. In this present format, this is almost going to be impossible for us to evaluate the integration. So what we will do, we will change the order of the integration. So instead of doing the integration with respect to x first, we are going to integrate with respect to y first. Remember, in order to do so, we are going to change the limits of x and y as well. And we will be able to do that once we understand the region of integration. So I see that my integration starts at x equal to y squared. That's the limit of x. And the upper limit of x is x equal to 4. So I'm going to draw these two graphs on the Cartesian coordinate system. X equal to y squared is the parabola with the axis of symmetry as x-axis, and it opens to the right. So the graph of x equal to y squared will be something like this. Let's call it x equal to y squared. That's the lower limit. The upper limit is the vertical line x equal to 4. So let's find out how much is the point of intersection over here. If x is equal to 4, I can take square roots on both sides and get 2 equal to absolute value of y. So y is equal to plus or minus 2. But since I'm on the first quadrant, y is positive, this point is going to be 4, 2. So at this point, the height is 2 units. So my limit for x tells me I'm integrating from a point on the parabola to a point on this vertical straight line. Whereas the limit in y-axis is going to be the limit of the run of this arbitrary point on the parabola. It can vary from the point 0, 0 to the point 4, 2. And think about the span of x-axis over this run. It starts at x equal to 0 and it goes all the way to x equal to 4. So now I am going to understand this region of integration R in terms of limits of y's first. Remember, the same region that I'm integrating, we will integrate with respect to y, but y now is going to start at the x-axis where y is 0, and it will go all the way to the parabola. Also remember, the point on the parabola is y equal to x squared, y squared equal to x. So when I take the square root, I get absolute value of y equal to square root of x. So y is equal to plus or minus square root of x. By the same argument that my point is in the first quadrant, I get positive y, so I take y equal to square root of x. So the limits of integration with respect to y is 0 to square root of x. I integrate the same function, square root of x sine x, but this time I integrate with respect to y first. And then the limits of x, as we have talked about, it is from 0 to 4 dx. So when I'm integrating with respect to y, I'm treating the x term as constant. So I will get integration 0 to 4 square root of x sine x. That's the constant, has nothing to do with the integration. Integration dy is just y. The limits are 0 to square root of x. Once I have this value, I'm going to integrate with respect to x finally. So if I plug in y equal to square root of x, I get square root of x sine x times square root of x. And I don't care about the value 0 because that makes the entire term equal to 0. Square root of x times square root of x is x. So I get 0 to 4 x sine x dx in the integration, which I will do by integration by parts. So first I keep x fixed and I integrate sine x, which gives me minus cosine x. So I get minus x cosine x. Integration has been done from 0 to 4. The integration by parts says that you need a minus. And now you're going to derive the fixed term, which is x. So you'll get 1. Again, antiderivative of sine x is minus cosine x. And I will integrate further with respect to x for the limits 0 to 4. So what I get? I get minus 4 cosine of 4 If I put 0 for x, I get 0, so I'm not writing it. Minus times minus is going to be a plus. Integration 0 to 4 cosine x dx. And remember, cosine x dx, integration is positive sine x, so you get minus 4 cosine 4 plus sine x, and then the limits are 0 to 4. Again, sine of 0 is 0, so I'm not bothered about that. Minus 4 cosine 4, if I put x equal to 4, I get sine of 4. The way I want you to answer this question is, first I want you to write this answer as a times cosine b plus c times sine d, and then find out a, b, c, d and add them. That will be your final answer. So I will write a times cosine b plus c times sine d, and I will realize a equal to -4, b equal to 4, c equal to 1, d equal to 4. So if I add all of them, a plus b plus c plus d, I get -4 plus 4 plus 1 plus 4, which is equal to 5. And that's the final answer to my question.